Hello students. In today's session, let's learn about transaction management in database management system. First, I would like to explain the meaning of the term transaction. Collection of operations that form a single logical unit of work are called transactions. A transaction is a unit of program execution that accesses and possibly updates various data items. Let's take an example of a simple transaction. Suppose a bank employee transfers rupees 50 from person A's account to person B's account. This very simple and small transaction involves several low-level tasks. We will see the steps involved in this transaction. We have to do some operations on two accounts, say account of person A and account of person B. You can see the steps in the slide. First, we have to open account A. It has its balance and thus we may consider as old balance in the sense before transaction. New balance is equal to old balance minus 50. A's balance is equal to new balance. Then close account A. Now, deduction of rupees 50 from A's account is done. Now, the deducted amount should be added in B's account. So, in B's account, the following steps will be performed. Open account B. Old balance is equal to B's balance. New balance is equal to balance plus 50. And B's balance is equal to the new balance. And then close account B. If the above statements are executed successfully, then we call this as a transaction. Now let us write the same transaction technically. You can look at the slide, it shows the transaction. We have statements like read of A equal to A minus 50, then write of A. The updated value of A will be written on the disk in this step. Then we have to read the value of B, then we have to change the value of B as B equal to B plus 50, then write of B. Now the value of B will be updated and it will be written on the disk. These statements can be called as a single transaction. Hope you are all clear with the definition of a transaction. Now I would like to introduce the properties of transaction. A transaction in a database system must maintain ACID properties. The properties ensure accuracy, completeness, and data integrity. ACID stands for atomicity, consistency, isolation, and durability. The first property, atomicity, states that in a transaction either all of its operations are executed or none of them should be executed. In the said example of transaction, if all the statements are executed successfully, then the transaction can be committed or saved. If failure happens, that prevents the transaction from completing its execution successfully. The basic idea behind ensuring atomicity is this: the database system keeps track of the old values of any data on which a transaction performs a write. This information is returned to a file called log file. If the transaction does not complete its execution, the database system restores the old values from the log to make it appear as though the transaction never executed. The second property is consistency. The consistency requirement in our example is that the sum of A and B be unchanged by the execution of the transaction. Suppose that before the execution of the transaction, the values of account A and B are 1000 and 2000 respectively. If the failure happens after write of A and before write of B operation, in this case the values of A and B reflected in the database are rupees 950 and rupees 2000. The system destroyed rupees 50 as a result of this failure, and we can notice that the sum of A plus B is no longer preserved. We term such a state an inconsistent state. Now let us move to the third property, isolation. In a database system where more than one transaction are being executed simultaneously and in parallel, the property of isolation states that all the transactions will be carried out and executed as if it is the only transaction in the system. No transaction will affect the existence of another transaction. And the fourth property, durability, ensures that after a transaction completes successfully, the changes it has made to the database persist even if there are system failures. So far, we have seen the basic concept and definition of transaction, followed by the properties of transaction. Now, let us explore the various states of a transaction. We have active state. It is the initial state the transaction stays in the state while it is executing. Partially committed. This is the state after the final statement of the transaction has been executed. Failed state. This is the state after the discovery that normal execution can no longer proceed. Aborted state. This is the state after the transaction has been rolled back and the database has been restored to its state prior to the state of the transaction. Committed state. This is the state after successful completion of the transaction. A transaction starts in the active state. When it finishes its final statement, it enters the partially committed state. At this point, the transaction has completed its execution, but it is still possible that it may have to be aborted. When the last information is returned to the disk, then the transaction is committed. A transaction enters failed state after the system determines that the transaction can no longer proceed. It may be because of the hardware or logical errors. Such a transaction must be rolled back. Then it enters the aborted state. Hope you have got what a transaction is, the properties of transaction, and states of a transaction. Until we meet again, it's bye from Naveen.